Okay, so hello everyone. I hope you can see my screen. Is that already working? Okay, perfect.
We can still see the slides, Nina.
Yes, this was my plan. Yes, so hello again. I want to guide you through the practical part of this day. So first of the first part is I just want to give you a very brief introduction of the architecture, but not as deep as Philip already did, just to name the components which we will be working on and how to get started. Then we will use a small example and go through that step by step to see which components have to be adjusted and what we have to implement to be able to show new node types, how to create them, delete them, and rename them. And I will finish off with a short outlook and yeah, some links for you. Yeah, so the first part, as Philip already mentioned earlier, we have three main components, the GLSP client, the GLSP server, and the model server. And basically, the model server is responsible to manage all the resource-related stuff, so the model files and so on, how to edit them, and just keeps track of our resource set. And the GLSP client and server are responsible for the diagram visualization, I would say, just very briefly. And this diagram will guide us through the practical part, I would say, because it shows a little bit how the flow is done. And I hope it will help you a little bit understand what, if we change something, which effect this has on our example. So for example, we can see here the first workflow, and this is the most general workflow. We will open a file, for example, then the GLSP server loads the file source from the model server. The model server returns the model information. Then we create our graphical model. And finally, the client will render all the views registered based on this graphical model we just created on the model server. So our example is a very, very simple class diagram. And I think, or I'm quite sure that every one of you already works a little bit with UML and do not have to explain that much what we see here. We see a very simple class diagram with two classes, student and course, which are connected by a relation edge. And how do we get there? How can we visualize that as a diagram? So first of all, we have the semantic model, and this is, as you can already guess, the UML model. I named that one course here, and this has a class student, a class course, and an association which connects those two. And on the other hand, there is the notation model. This is responsible, as also Julian already showed us before, to get an idea on how to display the diagram and to define its position, size, values, and so on. And we connect that by the unique IDs here. And to get a better understanding of what I just said, we join the dots here and can see such a diagram element uses both model information types, I would say. So the semantic model delivers us the information that this is a class representing a student, and the notation model gives us the information where this diagram element is located on the diagram canvas. So in putting this again together, how can GLSP display that in the diagram? It creates again the graphical model, as we already heard today. And for example, the information from the semantic model we can find here, that this element is a class element, has a label with the text student, and is positioned at x 176 and on the y-axis on 57, for example. So this is basically the background information we need for our example. So we will be working on such a course model, and we want to add now different type of node element to that. And again, our workflow diagram. Yeah, we'll just skip over that. Basically, to get started, you can then clone the basic repository, and we also provide several readmes there. And if you will then stumble over some problems, we are then always there to help you. But for this, for the example now, I just already started everything, and we will just really look into the coding part. So to understand better our workflow diagram I just showed you before, we will just step a little bit through what is really happening. What does it look like when I say we load the source model, we create a G model, and how does it look like if we render the class node, for example. So for that, I just show you the application itself for now. So we have a very simple class diagram here, as we already had a look at together. And to get to this point, we need to load the source model, create a G model, and then render the elements. And to do so, we will enable the breakpoints as seen on the slide already. So therefore, again, what will happen now if I want to open the course model? So basically, this is the first step I want to show you. We are in the model source loader on the GLSP server. And yeah, just to make a little bit clear, it might get a little bit confusing. I hope not too much for you, because I have the projects all in the same workspace, because it's also easier to implement than later on. But even if you would rewatch it, I hope you can distinguish then which part we are working on. And now we are on the GLSP server, and we try to fetch our file, our model files, and there we can see, I don't know if it's big enough, but we get the URI from the application, and then we hand it over to the model server, and the model server loads the resources for us and returns it back to the GLSP server. And then we are already in this third step of the workflow where we create the G model already. So here we have a G model factory which translates, as we already saw earlier, the semantic and the notation information into one graphical model. And if you want to have a look at how this G model looks like, we can, I don't know if it's big enough, but we can dig a little bit into and see, okay, we have 2 nodes and 1 edge there. And if we go a little bit deeper, we can see that there we have another compartment inside with a label, and this label has the text student. So basically what we looked at earlier, we already achieved here. And now the server side walkthrough is done, I would say. And if we have a look here, looks fine, most of all. And what's interesting now, we will jump back to the slides. We now did the server workflow, and now it's maybe also interesting to see what is happening on the client side if we open such an UML diagram. So therefore, I will just disable the breakpoints here. And it's also, of course, possible to debug in VS Code with our browser extension. And we do now the same thing here. Okay. I didn't even have to open it again, because even if you hover over it, it will render again from time to time. And what we can see here, we create a separate view for class element, and what we get is the information from the G model, and also we can again see, okay, this is an element from the type node class, and it has again children, the compartments, and if we are funny, we can look again and search for our label which says student. So we see we work on the same information here. This is again also the graphical model which was created by the GLSP server, and we now work with that and render this rectangle node with that information, and which is then displayed on our diagram canvas. So just again, yeah, we finished now our first workflow, or the first data flow, I would say, maybe a little bit accurate. So what? Just a little recap. We opened the file. We triggered the file loading, which was completed by the model server. Then with that information, we created the G model, and based on that, we are able to render the node to our liking, in that case, a rectangular node. So I hope that was not too overwhelming, but I think it will get a little bit more clear in the next part of this practical overview. So we will now add a new node to a new node type to our course model, and this will be an UML enumeration type. And to start off, I always suggest to just get a little bit more familiar with the semantic model. That means you can use any other UML editor, or just take a look what is available for the class diagram type in the UML specification. And for that, we can, for example, have a look in Eclipse itself, or you can also take a look at some other UML editor. I just linked here the Papyrus UML Lite editor. This already comes with a very simple diagram implementation here, and also offers quite a variety of different diagram types already. So you can just get a little bit familiar what is possible and how, for example, I already added here an enumeration type already, and we can take a look how does this look like in the model itself. So if we would start off, we could just extract that bit and see if this what would effect this would have on our existing course model, for example. But in general, I would say just get a little bit familiar with the new concepts you want to add, and yeah, then everything should be a little bit more easy to start off. Yeah, so here is another snippet fetched from the Eclipse version. I just show you. You can, of course, always just import your UML files in Eclipse and then open it with the simple UML editor, and then just play around a little bit and see how you can extend your current example. And this is what we will do now ourselves as well. So it's not only possible to open it as a diagram editor, you can, of course, open it as text as well. So we will just add another packaged element here with the type enumeration. It has some generated ID. And the same we do for the notation model. And what's very important here is that the IDs match, because that's the only way how they can be associated together in the G model then. And if we will open the UML model now, we will see, oh, it does not work. And why does it not work? Because yeah, this type of node is not registered at all. And now we have, this is now what we want to do next. So if we want to display a new element, what do we have to do? Of course, we have the first preliminary steps where we load the file and the model information, but we do not expect any updates there. What's the crucial part is that we have to integrate this new information when creating the G model, and then we will also create a separate view for that. But now let's focus on the G model creation. So what do we have to do to be able to define a new diagram type? So we will define a type in the UML config. We will define the diagram elements as new shape hints, as we already saw in Philip's presentation. And then we will just map all this information into how should the node element be comprised of. So yeah, let's just jump right into that. I will just close all this stuff we don't need anymore. So yeah, let's start off with the first and most important thing. This is the type of our new element. So just copy that there and edit our new type here. So, and then next on, we will configure this element type. And the benefit we have here now, we can take a little bit, at the class element type already, because this basically is like a sibling element type. So, and here, as we already created our new type, we define the enumeration type the same way as we do for the class one. And as we do not expect it to render any children, for example, the class already does that, it renders children, but we do not do that for the enumeration at this point, so we can just have a typo there, just okay. So, so just a quick recap. What did we do? We defined the type and we defined the diagram element, and now comes the little bit more interesting part. We want to create the G model information about our new element type. And for that, we jump into the node factory. And if we have a look at how it is done for the class node, I will just a little bit sneaky here and copy it over. And it's no surprise that we want, based on an enumeration, we want to create this new element type. So this is the first step. Yeah, what we also need to add is here, if the whole semantic annotation model information is walked through, then it's necessary that we also add this here in the create. Okay. So what do we do here? As we saw when we inspected the G model, such an element is always comprised of several different types of elements. So we have these compartments, we have the labels and so on, to be able to style them differently. And this is also what we do here. So we start off with a node builder, and this takes the type of an enumeration, and all the elements inside should be layouted in a vertical box, which means the elements inside will be layouted one beneath another. And we can add CSS classes here, of course. we apply the shape data from the notation model, and then we already come to the header, and this header is a compartment. Then again, we'll hold the information we want to have as a header, and we can skip the children part here. So, and how should our header look like? And as again, we can little bit take that from the class type. So let's see how this is built up. We have one compartment for the whole header, and then we want to provide another header icon, and this is not the icon, the class. Oops. Not the class icon, but the enumeration icon, and as the text, which was for the student class, for example, we can take this the same way and use the name of the enumeration for the header at the first glance. Okay, and now we will need to restart our GLSP server, of course, because we added new information there. So, and just circle back a little bit, what we did here, we now tried to map all the diagram information on the server, and we can take a look if we see already some changes there, because as we remember, we already inserted the enumeration information here in the model. But if we open the, it's already working. That's nice, because I did something wrong. I'm pretty sure, because that's a little bit weird, because usually you should see a red arrow icon there. But what we can see is it's already really working. How is that working? Okay, because now we would come to the next part where we would define the view on the client. Because without that, just with the Gmodel information, we just need to define how a new type is rendered, and therefore we just do it on the client side. And again, here we can just take over some information from. Now I know what I did wrong. Sorry for that. So we do again the same typing info we have done on the server side. I hope that works now. That's really interesting. Okay, so nevertheless, we define the type here, and what we have to do next is then to also map our new type to a certain view we want to. We want the element to be rendered as, and for that we do that on the client side. Again, for the node itself and for the icon type. And to see what we have here, this is the icon class, but we do not want that. We use a different icon here, and for the enumeration node itself, we also want to create a separate view, And this we just do also very quickly right now. So we make use of the class node again as well. And we can, this is the divider, but as we do not render any children, we just skip that, I would say. So, yeah, basically this is the same structure as for the class, except that we do not render any property children or something like that. Yeah, and basically, what is it?
I think you called your class that you created before enumerations view, node view.
Ah, thank you. That's very true. Thanks, Philip.
No worries.
So, and as we already saw, because I didn't rebuild my state first, we have here now different icon for enumeration instead of the class type. So basically, if we have a look at how we want to render our enumeration node type here, we can see that we succeeded partly, I would say, because our node displays currently only the name of our enumeration, but we want to have a separate header up here. And this is now the second part of the displaying of the enumeration, I would say. So what we want to do now is refine a little bit the structure of our element, and therefore we switch again to the classify node factory. So we want to restructure that. And how do we do that? So basically we maybe we have a short look again. So we have one label here and we want to insert another label above, and we want to capture them together into one compartment, would be my first guess. Yeah, so what do? We create another outer label here, and just for the ID utils, these are just additional utils. I just do not explain them in too much detail. Just give them a separate suffix to identify them a little bit more easier. So basically, create now another compartment which works as our outer header parent, I would say. And what we want to do next, then we want to create an additional label, as we already did for the name here. But that label should not. What do we want as text here? As we already saw on the slides, we just want to name it enumeration, like the enumeration UML class. So we just fetch that information from the UML class itself. And this is now the first element we want to add to this new compartment. So just add this type label here. And then we already have our header, which comprises of the icon plus the label, and we do not want to change that. So we add this compartment we already created here as well. So, and we want to return that instead of the original compartment. So I need to restart my server then. Looks good. So let's see if this worked out as we intended to. Okay, so we see that what's also very handy, you can of course always use the developer tools and inspect the structure of your elements, yeah, to see a little bit more information about that. So we can see that our auto component now has a header label, and again the original component which holds our label plus the icon here. So it looks okay, I would say, but not as nice as we intended to. So let's just circle back and see what we can improve here. So the name is maybe not the thing we wanted to display here. Right one, I would say. No, sorry, wrong line. Here. So we have different options here, and I would route to go for the simple name and to make it a little bit more accentuated. We add some brackets here. I don't know what to do. So it's interesting. Did I save it? Oh, I did not start it in debug, of course. These are the perks. So sorry for that. So now hopefully, yeah, that looks a little bit better. So we just adjusted our structure of the enumeration node and added this additional header here. And now we can double check, does it already look like we want it to? Almost. So I can show you now that we, let me rephrase it a little bit. We just adopted now the creation of the G model, and now we can take a look if it's also possible to change the view a little bit more than we already saw on the client. So I can show you now how it is possible to little bit or to adjust the information we get from the server a little bit on the client. So we want to replace those brackets with those French symbols, for example. This is just a showcase, so we can have a look at our enumeration view here. And for example, to fetch our first label, we can do it like a little bit quick and dirty, but just for this showcase, we will just fetch from the first compartment, again, the first compartment, and we know that there is our header label located. And for that, we just replace the brackets with this other type of symbol. And hopefully this works if we refresh the browser now. And we can see here that we now successfully edited or changed the view implementation for this node type. And yeah, it of course, as I already mentioned, it's not the most beautiful way to do it. So I can also propose a different solution here. For example, you could also define a custom label for which you will create a separate label view on the client, which only deals with that type of label, for example. But yeah, in the later course of your implementation, you will maybe then get back to that. But for now, we can let's get back there. But for now, we can see that we successfully changed the G model creation here and also adapted the view on the client side as well. So a lot of different possibilities here to change the way and look of your new element type here. So now we are finished with the first part of our step-by-step workflow here. And next up is what do we do if we want to create this new element on the diagram? Because as we can see, we have no possibility here to create a new enumeration at the moment. We can do that for the class or for a new property, but there is no possibility to do that for the enumeration type. So the first thing we need to implement is, of course, add an additional palette tool, as we saw it already. So therefore, we need to adjust the palette item provider on the server. And to make it look a little bit nicer, we define the CSS classes and the icons on the client that we have the same look and feel for this tool as we have for the others already. So then, as said, we go to the tool palette item provider. And as we already see here, for the classifiers, we have one entry for the class. So we just duplicate that and do the same one for the enumeration. And we define also our CSS class here. And we add that to the list of possible classifiers into the tool palette. So just as a quick intermediate check if that worked. Yeah, perfect. We see that we have the tool here, but we are lacking of the nicer look and feel by the CSS styling. So I just already prepared that previously and added new icons for the enumeration beforehand. It's a little bit hard to see. But basically what we need to do now is define our UML class as we used it already on the server. And we use it in the same way. And to define this icon CSS class, we can do it in the same way as we did for the class, for the UML class. So, yeah. Now let's refresh that, and then we can have a look if that was sufficient. Yeah, looks better now. If we want to have a look if this also is applicable for like a dark theme, we can see that the work we did by defining it for different theme types, we can see that it's also well visible for other types of or other theme types. Okay, so the first patch of work is already done, I would say. So now comes the next step, where we have to enrich the GLSP server to be able to trigger this operation we want to achieve and hand it then later on over to the model server. So just a little recap. We want to create in an UML model a new packaged element with the type enumeration, and we want to add a new model element in the notation model at the position we are clicking on. So this is the goal we want to achieve. The first step is then to take a look at how can we trigger this operation, and then how can we hand it over to the model server. And therefore, we take again look at the GLSP server, and what we just get a look at. This is our classifier node operation handler, and at the moment this handles element types or element type IDs, and this is currently only the type class. And of course, we want also to be able to create enumeration types. So we add that one here, and in the next case, as we already added the tool into the palette, we want then to be able to trigger this operation here. So we are not able to hand it over to the model server already, but what's maybe interesting to see if that would already work if we set the breakpoint here. So did not set it. So if we will now, why doesn't this work? Let's have another look, maybe. I think I already know what I probably forgot. Yeah, displaying the elements is all fine, but as we want, and we already talked about those type hints, or I can just show you again what the problem is here now. If you want to create an enumeration, the cursor indicates that we are not allowed to do that on the diagram canvas, and this is because we forgot to add a type hint here. So as we can see, the diagram graph, which is the diagram canvas in our case, was configured to allow classes as children, but this is of course not everything, and we need to add the enumeration there as well. So if we can, maybe just, so now we can see that the cursor is changing here and that we are able to add an enumeration onto the diagram canvas directly. But maybe the breakpoint was not that. I did not start it in. Is that the case? Sorry. Sometimes it'll. Oh, let's try that again. Or did I just disable the breakpoint and forgot to re-enable them? No. Okay. So now we can see that the node operation handler was triggered, and our operation we got here consists of the element type of enumeration and would then in the later course trigger the model server to add an enumeration. But as we did not implement that already, this is our next step to do. So I just so we can just take again another look how it is done for the UML class. Just take that down there. And there is nothing really special or different here. We just want to create a new enumeration based on that position we just clicked on, and we want to hand it over to the model server. So this is basically all the GLSP server has to do for now. Yes. And we will go on to the next component now. This is the model server, and the model server is now responsible to create the commands to edit the semantic and the notation model, and then to return the updated model back to the GLSP server so that we can update our G model and render it respectively again here. So let's check how it is done for the class element, I would say. So we have a command contribution, which basically helps us creating commands from outside the model server, I would phrase it. We can again reuse this implementation to some extent here, but I just want to highlight again that we do not, this is just a showcase here. So in your implementation, you can then generalize things and find better ways to reuse stuff. Of course, just to get an idea of how this can be implemented from scratch here. So what does this enumeration command contribution do? It takes the position we clicked on and the type, obviously, and then hands it over to the model server, such that the command contribution is also need to register that, of course, that the model server is aware what we want to do. Just add a binding here. So, and basically what we will hand then over to the model server is some kind of EMF command. And we can take again another look at how it is done for the class element. And as we recall, the changes we are about to do are on the semantic and on the notation model. So we use this kind of compound command here, and we want to create a semantic element for the enumeration and an notation element, which is a shape element on the notation model. So again, we can just take a look how it is done for the class. So no, that's not the wrong. So this basically is not a very interesting part of that, but it has to be done either way. Basically what we do here is just creating a new name for our class and then add it to the UML model. This is the part we have to do for the semantic side. And this, of course, also has to be adapted, right? Oh, and then we can circle back and see what we have to do for finishing up the compound command. Then we have to add the missing shape command. Of course, we could reuse stuff, as I already mentioned, but just for the sake of the showcase, implement it second time. Did I make again some spelling errors? Yeah. So what does this click here? It's an enumeration of the class. Just yeah, I should rename that as well. So basically, we have some errors left. So what we did, and maybe it was a little bit quickly now, we added the command contribution. We added the separate commands for editing the models, and now we can link that together in the model server access, which will be triggered by the GLSP server, as we already had a look at. And again, we will need to restart our servers. And now comes the most exciting part to see if this will work. So this, okay, clicked the wrong tool, right? Yeah, maybe you remember what I forgot, where we earlier had our breakpoint for the enumeration type. Of course, we have to adapt the model server access, or we have to redirect to the correct model server access class here. So let's just recheck what it does here. It calls this command contribution we just created on the model server. And now let's check if that works. And somehow it does not work. Okay, so then let's just debug into that and see what I was missing. So this already looks good. We are in the correct type here. And then we already created this enumeration command contribution. And we can dig a little bit into that. Maybe I just have to restart the model server as well, right? Let's take another look. But the goal of this step is now that we would be able to create this enumeration command contribution now, and then we had now we hit the correct place here, and we can see what I am missing, because I did not replace that here with the enumeration compound command, but left it with the class compound command, and this already explains why we get a class instead of an enumeration, of course. So let's try again. Now, as I started them in debug, I hopefully don't have to restart again. So now we go into the proper one. Yeah, this looks already better. And now let's check if that worked. That looks already quite nice. We created an enumeration with just an auto-generated name, which of course should not be class, but for the sake of the showcase, I think that's fine for us now. And let's take a look. We can see here that besides of the new class element we created, we also were able to create a new UML enumeration element with this auto-generated type. And if we just copy, for example, quickly our ID and we take a look, we can see that it's also already persisted in the notation model. So we can see how to create a new element type. Yeah, so what do I have next on that? Okay, just keep that. Just as a quick summary, what we did, we created a new creation tool. In our case, this was the tool in the tool palette. Then we hooked up into the operation handler and made sure that we trigger the model server access, which creates this command contribution type, which then tells the model server to execute the new a command to create new elements in the semantic and in the notation model. So this is already quite nice. Now the next step we want to accomplish to support an additional element type is to be able to delete that. And for that, what we can do is make use of the existing tools we already have. This is, for example, simply the delete key when you select an element, or there is also an eraser tool in the tool palette already. So the workflow here is now quite similar as we saw it for the creation. So we trigger an operation handler. This again triggers the model server access, which then tells the model server to execute some commands. And then we again create the G-model and let the client views render them. So basically any capabilities of the editor we want to add now, for our example, have basically the same workflow behind. So what we do or what we need to do for the delete enumeration is basically the same. We can take a look how this would look like for the class. So just use the deletion tool from the palette here. It just triggers the delete operation handler. We can take a look how this looks like. Here again, we have the distinction between the types. Call then the model server access, and which will then also create the commands that the model server is then able to execute. To save maybe a little bit of time, maybe I will not implement now all the commands by myself, but I suggest that we just look at the breakpoints and how we are able to, or if we are able to reconstruct this workflow here as well. Okay, so let's just restart here again. And as we can see here in the delete operation handler, I have this registered for the enumeration type. Then we just step through, I would say. So just set the according breakpoints here. So. So the concept is hopefully clear to you, that it's basically the same, that we trigger some operation handler here, registered for the enumeration type. Then we go further in. We again have this concept of the command contribution. We can take a look how this looks like. This is also very basic. Basically, we hand over the ID of our element such that the model server is later and then able to delete that. And then we can, I forgot. This is the wrong one, sorry. Basically, it's a little bit more. So let's just, if we delete that either via the palette tool or via the deletion key on our keyboard, we trigger the operation handler, and then we hand over to the model server, which is then again trying to delete the element from the semantic model and from the notation model. And what you can see below, that it's sometimes a little bit more complex than it looks like, because you have to remove any usages of the enumeration, for example, when it's used as a type in a class property, for example. And when we double check now, we save that, for example, then we can see that that our enumeration element was successfully removed from our notation model, semantic model, and we also have here only 3 elements left, and it was also successfully removed from the notation model. So yes, again, a short summary. We invoked the delete tool, we extended the operation handler, we created the command contribution and the commands, and then told the model server to execute those commands to remove the elements from the semantic and the notation model. So the last step in our step-by-step walkthrough showcase guide is renaming a node. And here again, we have a similar structure. We trigger the label edit operation handler, create the set commands on the model server. So this is the better overview maybe. We use the already existing label editing tool. We make use of the label edit operation handler. We trigger the model server access, which then triggers the model server to execute the set command of the enumeration name, of course, and not the class name. So maybe again, we take a look at the handler by setting some breakpoints. Okay, this is the label name. And also in the command, for example. So therefore we have to create another enumeration. And what we want to do now is to edit the label name, and to enable the renaming tool, we just double click on an editable label, which is also a feature we defined in the diagram configuration. So as, for example, we rename that to curriculum, as in our first revision of the example model. And we can see here that we are in the label edit operation handler, that the semantic element we get here is an enumeration one. And we again hand it over to the model server access, which then creates the command contribution and sends it over to the model server, which then only just resets its existing name to the new name. And this is curriculum, as we just entered there. And if we double check here and save it, we can see that this was also successfully executed and saved into our resources. If we would undo, for example, and save again, we can see the underlying semantic model was also updated as we would like it to. So yeah, again, a little summary, but I will skip that because I think you heard enough of me saying invoking a tool and triggering some model server access. But you can see the concept there. I hope I could make you a little bit or show you a little bit the transparency of which component is responsible for which part of the workflow. And yeah, I hope this will guide you then through the rest of the course when you will edit your own type diagram type. Yeah, so what I have prepared as well is the same workflow for the enumeration literal, but I provide it to you in a separate branch, which I just linked here. You can then just have a look when you dig into the programming phase. It just consists of the same parts of here, it just has a little bit different different needs in respect to rendering and stacking up the different child elements when creating the layout, for example, on the server. What is also very interesting is you can extend the model server, of course, as well. You can use it as it is. But for example, we did that already for fetching all the types here. For example, when we want to edit a property type here, for example, the string or integer, we are able to do that and assist the user with some auto-completion. And this list you can see here, which was invoked by control space, is fetched from a different endpoint from the model server we implemented ourselves. And of course, you can also do that if you find the need to fetch additional data from the model server yourself at some point. Yeah, this can then be used by some action handler, by some other endpoints. It's highly flexible there. I also added a Postman collection if you want to investigate a little bit more the endpoints of the model server, and also, for example, this custom endpoint to see how it really works when encapsulating and looking at the model server on its own, I would say. Yes, and this brings me to one of my last slides, just some further links and documentation. Philip also already linked some of them in his slides. I can just highly recommend the GLSP documentation. There you can find a lot of best practices and deeper information on how different concepts will work and so on, and also different discussions, issues, and so on. Yes, and if Philip, you're ready, then I would like to hand over to you for the conclusion.
Yeah, I'm ready, and I will keep it very, very short. I see already Dominic standing ready to take over. Thanks a lot, Nina. It was very, very great, I think. Of course, it's a lot to take in, and that's why I think the recording will come in very handy, and also the branches that Nina provides So please take the time to look into those and just try to replicate the work yourself based on those branches. It should be possible to step back and forth and investigate the changes. Just maybe 2 more sentences at the end before we hand over to Dominic. So first of all, I think this is a really, really cool project, and I hope you're as enthusiastic as at least I am about it, because it's really, just as Dominic said, it's really the first UML extension for VS Code that, at least with that power that you can really build UML models that you can then use for all the different other aspects like code generation and so on, by reusing the existing implementation that's available in Eclipse. That's really something completely new. And that's, I think, very cool to work in, with a lot of potential. New, I said new twice now. I think one of the key takeaways as well is that all the underlying technologies like GLSP and model server and so on, they are also very new, which is always very cool to work with a new technology stack. And it's also quite a modern technology stack, as we just saw in Nina's demonstration, which gives you a lot of flexibility. And I highly encourage you to take advantage, or try to take advantage of those new technology capabilities, like nice rendering, nice styling, and make it really look and feel great. However, the downside of new technologies is also that they are maybe not as mature and as stable as you might expect. But I would really also like to encourage you to take this as an advantage to not being afraid of looking into the code of the underlying frameworks, but just treat this code as if it would be your own. And that's really what open source is, I think, all about. To not stop at the borders of your implementation and the implementation of some other stuff, but really consider everything your own. And if you find something that should be improved, that can be improved, that is not working as you would expect, really ping us, or even better, open a bug report directly in the underlying frameworks. We are more than welcoming any sort of contributions, whether it's, of course, a fix, a new feature, or also even just a reproducible bug report. So I would really invite you to participate in this open source process. If you like to do that, just one thing, if you would like to collaborate on those levels as well, there is an Eclipse contributor agreement that you need to sign. This is really not something where you need to consult a lawyer. I mean, of course, I don't want to tell you that you shouldn't consult a lawyer, but it's really just some bookkeeping that you are allowed to make open source contributions by yourself or your employer. That's basically what this is about. So feel free to have a look at that, and please sign it if you want to contribute, if you want your code to live beyond the boundaries of this course. And with those romantic words, I would like to hand over back to Dominic. Thanks.